Question number 23. We got to find the volume of the square base pyramid for part A. The volume of the square base pyramid is equal to a third of the volume of the cuboid that this square base pyramid sits inside. So if you imagine sticking this pyramid inside a cuboid which is 10 centimeters long, 10 centimeters wide, and the same height as the pyramid, that's what the volume is. Okay, so what we need to do, we can see how long and how wide the cuboid have to be. We need to work out how high the cuboid has to be for this pyramid to fit inside. In order to do that, we need this distance here, the distance from the base to the highest point on the pyramid. Now we know that this length is 10 centimeters. We know that halfway along this side is 5 centimeters, and if we join up, we create a right angle triangle where we know two of the sides, therefore we can find the missing side, the line straight down the middle of this triangle. This side is 10, so 10 squared, take away 5 squared, it's 100, take away 25, which is 75, so this length here is the square root of 75. And then we can use Pythagoras again with this, which is 5 centimeters. This side we've just worked out is root 75, and then this side here is the third side in the right angle triangle, which is the side that we need to know to work out how high the pyramid is. So this side, root 75 squared, take away the shorter side we know. Well, root 75 squared is just 75, 5 squared is 25, take it away is 50, so this height here, the one that we're interested in, is root 50. So therefore the volume is equal to a third of the base length multiplied by the base width multiplied by the height, 1/3 multiplied by 10 multiplied by 10 multiplied by root 50 is equal to, correct to three significant figures, first, second, third, rounding to the nearest whole number this time, is 236 centimeters cubed. Okay, part B, find the size of the angle DAB. DAB. It's this angle here at the top that we want to know. Various ways of doing this. If you go onto the Durham Line and Gateway and have a look at the mark scheme, you'll see them all. Some of them involve using the cosine rule. The easiest one, which I will show you, involves finding out this angle, and this angle is the same. These two lines are the same length, so therefore this is an isosceles triangle. So if we can work out that length there, that angle there, then that angle there must be the same, and then we can use the fact that the angles in a triangle add up to 180 degrees to find the missing one that we want at the top. So drawing that triangle out again, that's 10 and that's 10. This is the one that we can find out first of all, and this is the one that we're interested in. Okay, we have worked out this line in the previous part of the question. That's the height of the pyramid, and that's root 50. This is opposite this angle. This is the hypotenuse of this right angle triangle, therefore we can use sine where the opposite is root 50, the hypotenuse is 10, therefore the angle is the inverse sine of root 50 over 10. To work out that this angle here is 45 degrees. That one's 45 degrees. That one's also 45 degrees because it's an isosceles triangle. 45 plus 45 is 90. What must this one be? Well, this one must be 90 degrees because the angles in a triangle add up to make 180 degrees.